I'm Michael Staib. I'm the author of the Hot Chocolate GraphQL library for .NET. And today I want to talk about GraphQL observability. Actually, this talk has just very few slides, because what I want to do is unpack problems that we are facing in GraphQL libraries when we put them to production. So we are going to dig into a GraphQL service and trying to explore what the issues with the service are, and how we can fix them, and how we can make them visible. So when the talk's name is here, GraphQL Observability, that is actually the aim where we want to be at the end of this talk. So why GraphQL Observability? So GraphQL has some unique challenges, I would say, when you want to make performance impact visible to the developers. And that has to do with its nature. Like if we look at this simple GraphQL query, it's actually, when I explain GraphQL, getting started to GraphQL, I always start with this slide, or it's always at the very beginning. And I tell people this is a hello world of GraphQL. And it essentially asks here for the name of the currently signed in user. And if we send something like this to our GraphQL server, we get exactly what we asked for. I mean, that's a great thing with GraphQL, right? But it's also one of the challenges, because a user then can just ask for more data. And that means that I don't really know the performance characteristics of my backend. So how do I determine if everything goes right, if my service performs well, or if the front-end developers now created queries that are so huge that I really have an impact on my backend. And since in GraphQL we can really dig deep, we could get into related objects and so on and so forth. Really could create huge query trees. So typically, and that is how many people start with GraphQL, is to put a thin layer of GraphQL over their business layers. If we look at that, it might be easy to figure out where performance issues are, because GraphQL is very thin. We just have this business layer. We should know what we are talking about. But in many setups, GraphQL is actually deployed like this, where we have microservices beneath it, REST services. These REST services then again use databases, use other services. This could be a huge tree. So selecting just fields in my query then poses a risk or a challenge to me, because I don't really know how many systems are impacted by my queries. And another thing, how do I actually know what queries my front-end developers are doing with my system? How do I find that out? So the big question is then, how do we find production issues? Because typically it's like this: you deployed your service and then it's done for you, and then somebody comes along and asks, maybe, did you deploy something new? Why? Because something is not behaving as before. Maybe we are having issues. Things are getting slower. And this is actually where we can start in a little exploration. Let's say we have a little application. Let me just start it. I have here Visual Studio Code. And that is actually my backend. Let me just start it up. And we are not just looking from the backend at it first. let's actually look at the application. So this is our backend. Let me just clear that here. And then that comes actually with a front end. And that's where the problems actually always begin. Okay, let me refresh that. So that's my front end application. Let's redo that. So server's warmed up. It actually performs very well. But let's say that the users reported performance issues, and maybe also some system administrator told us about huge pressure on our system. So how would we approach this? Find out what is wrong with our system, because when I refresh that application here, it performs very well. 170 milliseconds for getting all this data that we see here. And I mean, we could try and go to another page, but it's kind of performs very, very well. So typically that's where we start. Yeah, let's have a look at the logs. Or let's have a look at our logs. Our logs we always post to the console. Like that's often how projects start. And then we can already see, yeah, that's quite a lot of stuff here. So let's clear that, maybe, and then have a look at a very simple request. So let's go maybe on the Bitcoin here. That's our cryptocurrency, a single cryptocurrency, and let's have a look what is being logged. So we again can see that the request times, yeah, they vary 170 to 350 milliseconds. So there is a variance, but it doesn't feel so bad. And actually, there's no log because in our application, we are using a store. That means we are caching the objects. That's why my local application actually performs so well. So let's refresh that. So my store is destroyed, and it just fetches all the objects that I need. And that now for just this single page, I can already see that there is a lot going on. Like, holy shit, so much SQL. You can see we are selecting here the users, maybe a specific user. Then we are getting the Bitcoin base data. We are getting like price data, and actually we are getting a lot of price data. Oh no, just a single one here. Then we are getting watch list, and you can see there's a lot going on. But then we are also doing HTTP calls here. We're going to a REST service, and we're getting the price for our Bitcoin here. And then there's more SQL. Okay, that's already an indicator where we could say that doesn't feel right, but we actually have no clue at this point. But a lot of applications that I also came to experience in production at projects, they just have logging. And it's very difficult to understand how your system works from a logging standpoint, because you have this huge data input that you have to sift through. I mean, there are tools, and console logging is maybe not the best approach to do it, but it's a good enough approach on my local system. Okay, so how would I go in GraphQL about that? So when people start with GraphQL, they always hear about something that is called Apollo tracing. And that is a more GraphQL way to look at performance data of our resolvers, because I saw there's a lot going on here, but where is that actually going on, and which query is causing this? So what we could do, and this is also still a very naive way in looking at that, we could maybe just grab our GraphQL query here. Let me just go at that. Let's refresh that. Now we get our GraphQL query here. We could just copy it, copy the value, then go into our GraphQL IDE of choice and have a look at it. Okay. Okay. So this is actually the data that the client requests from our backend when it starts. You can see, so this is a view container query here. That's the name of our operation. It's good to know. We keep that in mind. And then you can see we have a lot of fragments here, and each fragment fetches a certain amount of data. Like here's some base data, description. Then we have here the price data we are getting. Then we are actually fetching for our chart. We are fetching the change data, so the price points in the historic price points over the day. And there's more price data we are actually fetching here. So we can just run that also here, again, our backend, but it dies. Yeah, it dies because it needs a variable here. We also can just grab that from our request here, just copy and paste into our variables, and then we can actually run it and we get the data. Let's rerun it, and you can see it. But here you, for the first time, can see a variance. It's 900 milliseconds to 200 milliseconds. So there is variance. But if you typically debug that, if you're in the range of 100 to 200 milliseconds, you will not see a problem here locally, because you're just running this single instance. That's why when you publish such a thing to production, you actually are surprised then that your system maybe goes down. Okay, let's have a look at what we can do in GraphQL to make it a bit more visible what's going on. And I said there's something called Apollo tracing. That's a naive approach, but you will get an idea of how your resolvers perform actually. So we can go in here into our GraphQL server, and with Hot Chocolate we can just chain in our configuration. So this at GraphQL server is actually where our server configuration starts, and then we can just chain in. So in this instance, we are chaining in at Apollo tracing. And then we say always trace. It's not a good idea, actually. You will see, because if you always produce traces, you will waste a lot of performance. And that's exactly what we don't want to do. But it's a good way to debug locally a bit. Okay, so if we run that, we actually get now this extra data down here. You can see. We should. We don't. Maybe. Let me check. This can be, because in Banana Cake, but we actually don't support it. So let's go to Playground and put it in here. There's also a service called Apollo Studio, which lets you essentially send these tracing data to it. Okay. Are we connected? Yes. Okay, again, we post our query in here. And then we're gonna analyze it. So Playground now has down, let me get the way, has down here this tracing blade. And if we run that query, you can see we get some performance inside here. And if we look at that, we actually, it doesn't look so bad. Like we have this price change is 62 milliseconds. And this history, okay, we know it goes to resting point 215 milliseconds. So we get an idea over our resolvers here, but we don't actually get real insights. And that is the problem with the approach of logging and tracing when you look at it isolated. Let me go back to my slides. Okay, why I unpack that in this way is actually that we don't really get insights in our system, and everything is here very isolated. We cannot really see what's going on. We maybe see there is an issue, we have this variance. We could go now through the code, we could look at the resolvers, what are they doing, where are these things, where are these SQL queries caused, and so on and so forth. But it can be very, very difficult to see the relation between distributed systems. So this is where this concept of observability comes in. And that is essentially the ability to measure how healthy and how performant your system is by collecting data, by looking at the tracing data, at the logging data, at the metrics, and so forth. So observability, if you go 2 or 3 years back, was very difficult to achieve. It was possible. Like I worked at a large project and we built our own observability providers. We injected into each HTTP request. We injected correlation IDs. We injected it into our messaging systems, extra metadata to trace how the logging flow is. And it took a lot of effort. And there was a single software engineer just working on that thing. And it wasn't enough to have a really qualitative solution. So over the years, there were a lot of approaches to tackle this problem. And that's actually where OpenTelemetry comes in. And starting with .NET 6, using OpenTelemetry becomes very, very easy. There are a couple of APIs now in .NET, a new activity API where it's easy to produce traces, to use these things that we call spans, to create them and to essentially collect and produce this tracing data. So when we talk about OpenTelemetry, we have a couple of terms here. Like we want to instrument our API. Essentially, we want to add special metadata to it to later work with that in a certain tooling that brings us these observability concepts. By default, OpenTelemetry doesn't automatically make your system observable, but it's essentially instrumenting your APIs. And by doing this instrumentation, we then generate data that we can use, that we can collect to ship to an actual backend. We call that export. And these are actually the terms that are important. We instrument, we generate the data, we collect it, and then we ship it to a tool. There are a lot of tools out there. We are using today Elastic, which is very good, but there are others that are also very good, like Jaeger, maybe you heard of it, or Honeycomb, and so forth. So we also talk about Meld when we talk about OpenTelemetry. And Meld, if you hear it, you think, what's that? It actually just means metrics, events, logs, and telemetry. Because these 4 things make our system observable. So what are metrics? Metrics are things that we collect, maybe the CPU usage of your system could be a metric. How much memory you're using, how often your garbage collector is running. Then are metrics. And a lot of these metrics, Microsoft already implemented. There are default metrics about HTTP, about ASP.NET Core, about garbage collection and stuff like that. Then we have events. That is essentially when something happens on your system. So I actually I read a good article about that, and the lady explaining that there said, okay, events, you essentially can think of a vending machine where you push a button and then something comes out. That could be an event. And when we talk about that in an OpenTelemetry context, we often annotate these events with metadata. And then you can use these metadata and these events to analyze that in an observability context. And we will have a look at that, how we can do that in Elastic. Oh. Yeah, and the logs essentially is just the standard logs that you had before, just that we now, with the traces, can put into spans and can put into context. Yeah. So you still have your logs, and combined with the traces are these spans that we can put around our more important things. We will have a look at that, what that means, to measure what's happening between systems. So typically, when we look at our app, we have some kind of an API that we use to instrument our application. Then we have the OpenTelemetry SDK that is processing these events, logs that we get here. And then we have something called an exporter that will ship these data somewhere. Like we could have a Jaeger exporter and then locally look at these things. Or we could have like an additional service, an OpenTelemetry collector. And if you're doing OpenTelemetry at scale, you will actually use an OpenTelemetry collector because you can better arrange how much collector instances you want to better distribute the performance that this takes. Because also instrumenting your services doesn't come free. So in a typical Kubernetes cluster, you might have 2 collectors or so, and then you essentially offload the processing to the collector instead of each of your applications. And then this collector has again also an exporter, maybe, and can export the data or push the data to a telemetry backend. In our setup, we will use their Elastic APM for observability. So let's go a bit in our code and get more insights in our system. Just by the way, so I put here very naively Apollo tracing always in. Don't do that because it adds a huge payload to your system. So if you want to use Apollo tracing tooling, then set it to on demand, and that means you essentially can pass in a header, I think it was x-tracing, and then ask for telemetry data. Also this, you should secure that and only allow certain users to ask for that data. Otherwise you also open with Apollo tracing some security risks that somebody could use that to bring your system down. Like because you're producing that a lot of data and sending it down as a JSON. Okay, so let's put OpenTelemetry into our system. So the first thing, I already put some libraries in here. And at the moment, you can see that, like my OpenTelemetry versions are RC versions here, handpicked, because it's an ongoing project. We started to see the abilities in .NET 6, and you can see it's now in the release candidate stage, so it's getting more mature, but it's new, right? And I also put these OpenTelemetry APIs already in here, and you really need to know which versions at the moment go together. Still, if you're starting with this, I mean, we are using that already at scale because we thought when at our projects where we started with Elastic, should we go for the native Elastic APIs that are available, or should we invest already in OpenTelemetry? And since it's a new project, we went with OpenTelemetry because that is a more standardized way and allows me later, if I want to move away from Elastic to Jaeger or use different tooling additionally, to produce the data for it and not be tied into Elastic itself. So if you have a new project, definitely start with OpenTelemetry. If you're already using proprietary APIs, you can wait a bit, but you will see it will give us a lot of insights here. Okay. So the second thing for Hot Chocolate I put in was the Hot Chocolate diagnostic. And that essentially gives us insights into the Hot Chocolate inner workings, essentially produces OpenTelemetry data for GraphQL. And down here you see this OpenTelemetry instrumentation ASP.NET Core and HTTP. These two providers will give us telemetry events from the ASP.NET Core engine and also from the HTTP client. We will see in a second what that means. So the first thing that we actually have to do with our API is to declare the metadata about our API. Let me put that up here. So we would use something called the resource builder to essentially tell OpenTelemetry what service it is. You can see my service, we call it Coin API because it's about cryptocurrencies. Then we have a namespace here, which I can use for filtering later. And I'm telling it it's version 2. I also can provide here some things about the environment. For instance, this is a development environment here. And I'm using the .NET SDK, and I can provide some versioning here. So this is some metadata, what you can filter on in the OpenTelemetry context later. The second thing is I need to put some instrumentation services in here. Let's do that. So let's first put the tracing in. So add OpenTelemetry tracing. I said there are 4 parts to OpenTelemetry. This is the tracing part, and you can see I added here HTTP client instrumentation, ASP.NET Core instrumentation, and Hot Chocolate instrumentation. The second thing is I'm using an OTLP exporter. So what is that? OTLP stands for OpenTelemetry protocol, and it allows me to push to an OpenTelemetry collector. So typically, you would, let me just open this. You would set up an OpenTelemetry collector and so forth. I'm not doing that here because it's more work. So this is, for instance, you have such a YAML file where you can configure your OpenTelemetry collector and can tell it essentially that it shall push the data to Elastic. So we would put here some authentication data in so that it can communicate with Elastic. And there is also from Elastic like this Docker Compose file, which essentially gives you a local Elastic cluster set up already with the OpenTelemetry collector. So it's quite easy to set it up. But for a demo, it creates a lot of overhead. So what I did, and don't do it in your production system, is I push directly to Elastic. Yeah, because Elastic actually understands the OTLP protocol. It's the same protocol that the collector has, right? But it's if you want to have a really performant infrastructure and reliable infrastructure, go with the collectors. Okay, so the second thing we do is we add the metrics. And at the moment, we don't have any Hot Chocolate metrics, but you can put in your own metrics that you want to collect about Hot Chocolate, and we will have a look at that. Okay, again, we have the HTTP metrics, the ASP.NET Core metrics, and we push it to the same cluster. So with this, we actually put everything in. there's one more thing. So we are telling here our system to collect hot chocolate instrumentation events, but we still have to tell hot chocolate that it should produce these events. So we say add instrumentation, and now the execution engine will actually produce these events, because we didn't want to put them in by default, because as I said, they have some performance impact. Okay, let's run that. And then produce some calls. So I'm just executing this a couple of times. So we get some data. And then we are going to Elastic. So Elastic starts around at $40, just if you're interested. What I have here is a $40 cluster. But as I said, you could also run it locally. It's open source. They have a dual license. That's something new, because Amazon started stealing their stuff. But it's essentially you can run it for free or in the cloud. Okay, so here's my NDC demo cluster. Let's go in that. Oh, conference connection. So, and most people, when I tell them Elastic and observability, they are, what? Elastic is for searching. It is for searching, but the observability is built essentially on the Elasticsearch engine. So let's go in the observability here, and you can see I already have some log rating here. There are no metrics yet that are interesting for me. So, but I can see that the APM has already some throughput data. And what we are going to look at is now the metric side, the tracing side, which is down here in the APM level. I can go here and have already a look. I can see there's my coin API and there's a price API. The price API is actually my price data, the REST calls that we did. I also instrumented that. So the system knows that there is a price API. I can, before we go in the tracing, I actually can have a look at the service map. So because I produced traces here, Elastic was able to identify dependencies between my services, because it traces the logs between the services, essentially by injecting correlation IDs into the HTTP requests and so forth, and so on. And also it can trace, like it can see, okay, the price API uses a Postgres SQL database. So it knows a bit about my setup here just from looking at these traces. And now I can essentially drill into that. So let's go for the coin API here. And you can see here I have my environment, so I can filter that to the development environment. And then I can see here this GraphQL, which is not ideal, because we talked about GraphQL having so much variance, because a user can actually send any query to my endpoint, and now any GraphQL query actually is tracked under the same endpoint. This is not good. This is a specific problem that we now have because we are using the HTTP telemetry together with GraphQL. I can see there's a query, but for filtering and looking at these things, it's actually not good how we organize this. So there is a way around that to make that better. So before we go into the telemetry data here, let's just fix that up, go back to our service, and put some options into here. So we can say, I want to rewrite my telemetry events, and essentially, I want to rename the root activity, and I'll show you in a second why. And also, include the GraphQL document. So by default, we don't do that. You could choose to do that only on maybe your testing environments, because it's an extra payload. It will send the whole GraphQL query to the telemetry backend. Or it doesn't have such an impact, you don't have that scale, then you just can include it always. Okay, so I did these two things. But still, I don't want to waste so much time there. It's not an ideal setup. So in OpenTelemetry, we can actually enrich the events that we are sending to our backend. And we are going to do that here. And we are going to rename the root level for Elastic so that it's nice and tidy in our dashboard. So this actually works through something that we call an activity enricher. So we say custom activity enricher.cs. And I already prepared this guy here. So this is an activity enricher. It essentially inherits from activity enricher. And I just generate the constructor here. We don't have to care about what is being passed in. It's essentially the options and the pool to efficiently generate strings. Okay, and then I can override how these data for my Elastic cluster are being enriched with additional data. For instance, I can say, create the root activity name here. And in my case, I show you why I do that in a second. I'm just saying, okay, the root activity name shall be the display name. And then we are going to put that into our configuration here. And then we rerun the queries a couple of times and look at the traces. So let's say builder has singleton. We want the activity enricher here. Activity enricher. Enricher is our custom enricher. Okay. With that, let's do that again. Go to banana cake pop here and run these queries just a couple of times that we actually can see them in our system and have a variance of traces actually. Okay. Okay, go here. We are going back to our coin API and let's refresh that. And now you can see that the traces that we produce actually have like this format that looks almost like our query. What we are not posting the whole query here because it's the title, but we will tell you the name of the query that our client application uses. And we also will tell you about the root field this query uses. Okay, from this, we can then drill in. We down here see the latency distribution of our event. So where are most of the requests? You can see, okay, some are in 200 milliseconds. This one was when the server was not warm, was 2 seconds. And then we have here 95 percentile of the requests essentially are in this bucket. Okay, let me just drill into some of these. So we can see what really happens here now. This is the GraphQL event. I can look at the metadata. Here I can see the actual GraphQL query, but I also have some other information like the hash. Like I can see that it's a single HTTP request. It was not batched and things about the transport. And I can also see like my resolvers. We only report the resolvers that actually do something async. So if you just have a field, like a string, like a name of something, we will not report it because it's just data that is useless. But you can already see, okay, asset by symbol is a field that costs me 10 milliseconds. Then we have this price field. And then you can see here some batch shapes that will do HTTP requests. You can see there is something going to the change service here. And each call to this change service will actually do 2 database calls. This is the first indicator where we should say, okay, something may be wrong. But if it's just one call, why not? But then we can see it's actually 2 calls in this instance that are going to this service. So it's 2 database calls. And that's just for one asset. So if we go in our client and look at maybe a list of assets, maybe let's do that. Then we get more pressure on our system. So we go here, let's produce a couple of these events. Okay, so let's go in our overview, Coin API. Let's refresh it. And you can see now we really get all the insights from our client now. You can see all the queries that are coming in. Here's the dashboard query. And you can see now we have a list, and you can see here every price field actually calls something. And now you see a lot more database usage. So this might be where our problem lies with our backend, which then at scale might produce the problem. And you can see there's a lot of things going on. And from that, we could drill into our APIs. I mean, this is really not looking so good. And I can see actually what is being called here. I can look at my HTTP request and now could have a look at this new API. So what's being called, you can see, okay, it's a batched request. So it should be fast. We are batching actually the HTTP request for multiple cryptocurrencies to this. So actually it should be fast. But then let's have a look at the SQL. So first we are just looking at how many things we have. But then we are doing a percentage change call here. That's good. But we are just getting one item. And you can see we're doing this again. And we're doing this call again. You can see these calls are repeated. So for each cryptocurrency that we are actually batching to our downstream service, we are doing again and again these calls. And this is something that where you couldn't have expected that from the GraphQL layer. The problem actually is not in our GraphQL layer. It's actually in this downstream service that we're using, where they didn't implement the batching maybe well. So the version 2 of this endpoint actually introduced a problem to our GraphQL layer. And what we saw in projects where we introduced such observability, you automatically found a lot of issues, even if you didn't know about them, because it now makes it transparent how these different distributed systems work together. Like the GraphQL layer uses some other service down here. Maybe you even have another service under that. And now you see what these services are doing, how they are communicating, and what they are doing inefficiently. So we could fix that probably. Let's do that quickly. We probably could, in this instance, I know I just have to roll back the API change that the developer did. So I could go in my data loader. That's where we do the batching and where we do the price change. And I just could go for the old API again and say, let's go. .NET run. Then we could go to our client again. Run these a couple of times so that we get some new data. Okay. So there is one more thing after that. So we could, again, look at this. Probably some of the things should have changed now. Let's look at this lower thing here. And you can see now I'm using my old my old version of the service, and suddenly I'm just using one database call. So this is how observability makes it very transparent, or the combination of OpenTelemetry and Elastic makes it very transparent what is going on between my systems. So that's something I haven't set up here, but we are using that actually, and that is machine learning. So you can actually use machine learning to look at things that are different. Like maybe you're running your system over a long time and we have these tracing data, and suddenly you do such a change and now you have multiple more cores to your downstream services. Then Elastic can actually send you an email. Look, your query now uses a lot more database connection as before. And then an engineer could look at that before you run into the problem where the user calls you that the system is running into timeouts. And that is with these events. It becomes a lot easier if you're using something like metrics here, and you can use custom metrics. And it actually is quite simple to integrate them also with Hot Chocolate and our query engine. We have a couple of things, like we have a cost analysis API. So you can actually use a different execution pipeline here. We could go for the use, actually it's in the default pipeline. So you can set the options, add request options. Modify request options. Sorry for that. And tell our system to analyze the cost of a GraphQL query. The cost of a GraphQL query, let me just show you that. And because we are running out of time, I'm not going too deep into that, but it's a good way to actually provide additional metrics to your system. So we could say complexity. Let me just get this here. Complexity.enable. And this will enable our complexity analysis on GraphQL queries. We will look at how the query is structured, how many async fields you have, and essentially generate a number that describes the weight of this query for your system. And we could send that as a metric to your telemetry backend. And then if the cost of queries increases because your developers your front-end developers are using more and more fields, or it becomes more and more complex queries, then you essentially also can put like events on top of that and see, okay, that's actually wrong. We need maybe to introduce something different here, or maybe we have to scale out because that's our new use case, our new normal, and things like that. So I enabled that. And this would now write for every query the complexity into our metadata. I just to force the error, because we don't have time to actually integrate that. Let me do the max allowed query. Let me just put it to 5, just to cause the error. Let's run that, and then you will see what I mean. Is it running? Okay, so if I run that, it actually leads to an error. But what I wanted to show here is, so the execution engine now weights these queries, and it says, okay, the complexity of this query is 135. And the allowed complexity actually is just to cause this error. But this metric we could now send to Elastic, because we set enable complexity here. And then we could use that to weight our query and use machine learning to find out if a query goes out of range, should be allowed, or things like that. In order to do that, we would use the new API in .NET. So it's called Meter. I'm not integrating that now, but just to give you a hint where you can look. And you can give a meter a name, like we could call this foo.bar, like we always have these dot notation. And you also could give it a version, and then we could, a version is always good, because if you change the structure of it over time. And then you could essentially create counters or produce some metric data. And this would now be automatically integrated, because we could then take this key here and just tell our metrics here that we are adding instrumentation and that we want to listen to that specific meter. So this is how you could integrate even more into your observability solution. We are at the end of our talk here. This is my Twitter handle if you want to connect. Hot chocolate repository is here. So all the code you will find there. If you have questions, I'm available. You can also come afterwards to me, and if you want to have a chat. Yeah, if you like our project, would be great. If you star it, if you don't, it's also okay. Questions? Okay, that was a quick dive into the problems that you could face when you put GraphQL to production and how you can solve the issues that you are facing there. Okay.